Hello, my dear students. Welcome to EPG Pathshala. I am Dr. D.C. Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. Here I am presenting the paper Technology of Spices and Condiments. You know, the bleaching is an important step in the ginger processing, and without it, it may not appeal to the consumers. And this particular process of bleaching in the case of ginger processing will be explained to you with its merits and demerits by my co-author Ms. Kulsum Jan.
Hello students, welcome to EPG Pathshala. I am Kulsum Jan from Sant Longowal Institute of Engineering and Technology. Today I am going to talk about module number 26 of paper number 10, Technology of Spices and Condiments. In this module, we will learn about the ginger essential oil and oleoresins. So, the spice contains a lot of oleoresins. These oleoresins are the concentrated liquid from the spices that reproduce the character of the representative spice fully. The spice oils are the oils distilled off from the spices at the initial stage before subject to solvent extraction. Spice oleoresins are largely used for flavoring of food, particularly by large-scale of food processing and flavoring industries like meat, canning, sauces, soft drinks, pharmaceutical preparations, perfumery, and soap, tobacco, confectionery, and bakery. The demand of spice oils and oleoresins in the developed countries is increasing day by day. As more and more spicy snacks are being introduced by fast food chains with standardized tastes, the traditional drying methods used by farmers to dry ginger are varied, haphazard, and risky, resulting in mold growth, loss of some volatile oils by evaporation, and destruction of some heat-sensitive pungent properties. As far as the ginger is concerned, the name itself supports the view. The Sanskrit name Zingibera gave rise to Greek Zingiber and the later generic name Zingiber. So, ginger, Zingiber officinae rosaceae, is a monocotyledon belonging to the family Zingiberaceae and to the order Zingiberales. It is a perennial herb with a large, solid, tough, horizontal rhizome consisting of a series of many pre-resistant roundish joints, pale yellow in color inside and covered with pale slippery brown skin, ringed with leaf scars and each marked at the summit by large circular flat scar. Much branched, the new joints coming off below the terminal scars. The root is warming to the body, slightly antiseptic, and promotes internal secretion. Essential oils are characterized by the overall capacity to generate aroma and flavor. Therefore, they are widely used as flavoring additives in food production, fragrances, in cosmetics, and components of soaps, air fresheners, and detergents. Obtained from fresh dried rhizomes, the best ginger oil is essential oils extracted from plants also contain the biologically active fraction of chemicals that are biosynthesized in nature and very often possess pesticides, possesses pesticidal, insecticidal, and antibacterial properties. An important field of application is also clinical aromatherapy, in which oils are heated and volatilized. Chemically, the term essential oil refers to any class of volatile oil containing a multipart mixture of monoterpenoids, smaller amount of sequesterpenoids, and other volatile aromatic compounds steam distilled from different parts of plants. Up to now, most reports of compositional variation of essential oils deal with plant extracts obtained directly by steam distillation, obtained from whole rhizome that are unpeeled. Essential oils are extracted from plants also contain the biologically active fractions of chemicals that are biosynthesized in nature and very often possess pesticidal, insecticidal, and antibacterial properties. The applicability of the essential oils is generally in clinical aromatherapy, cosmetic industry, and food industry. Pharmaceutical industry is an important field for the application of these essential oils. Up to now, most reports of compositional variation of essential oils deals with plant extracts obtained directly by steam distillation. There are different methods for the extraction of essential oils. The oil from the dried rhizomes will contain fewer of the low boiling point volatile compounds. The compounds that give ginger its flavor and aroma, as these will have evaporated during the drying process. Ginger oil is obtained using a process of steam distillation. The dried rhizomes are ground to a coarse powder and loaded into a still. Spice oils can be separated by steam distillation. Ginger is most suitable for industrial distillation and extraction of volatile oils and oleoresins. All the flavor attributes of aroma, taste, and color are required. Hence, only solvent extracted oleoresins will be complete extractive. When milled spices are stored, their essential oil evaporate over time. Microencapsulation preserves the valuable flavors. In this process, the milled particles are microencapsulated and then sterilized at a mild temperature to reduce the germ count. Microencapsulated spices currently are making an outstanding contribution to targeted flavor development in end products, particularly when it comes to a special manufacturing processes in the food industry. Dried ginger contains 1 to 3% essential oil, 5 to 10% oleoresin, 50 to 55% starch, and 7 to 12% moisture content, with protein, fiber, fat, and ash as its other constituents. Ginger oleoresin is obtained by extraction of powdered dry ginger with suitable organic solvents like alcohol, acetone, and ethylene dichloride. Concentration of solvent extract under vacuum and complete removal of traces of solvent yields oleoresin of ginger. They yield flavor and pungency of extracted oleoresin vary with cultivars, maturity of rhizome, choice of solvent, and the method of extraction employed. Generally, yield of 3.9 to 9.3% with an average of 6.5% when dry weight of ginger is obtained. Commercial ginger oleoresin usually has a volatile oil content of 25 to 30% and replacement strength of 1 kg oleoresin for 28 kg good quality ground spice. They are offered to the consumers in liquid form and dispensed on sugar and salt. Steam is passed through the powder which extracts the volatile oil components. The steam is then condensed with cold water. As the steam condenses, the oil separates out of the steam water and can be collected. In India, the material is redistilled to get the maximum yield of oil. The yield of oil from dried ginger rhizomes is between 1.5 to 3%. The remaining rhizome powder contains about 50% starch and can be used for animal feed. It is sometimes dried and ground to make an inferior spice. The steam with the essential oil will be condensed into liquid phase and will be collected in the beaker. Lastly, the two liquids will be separated to get high quality and quality of the essential oil. The fire from burner that burns the tank and produces steam in the tank must be well controlled. The extractor from this process will have three main parts. First, the steam will be supplied into the vessel. The steam will contact to the raw material and force the essential oil out of its raw material. Second, a condenser will be used to change the mixture of vapors to be two separated layers of water and essential oil. The two separated mixtures occurs because of the difference in density. Lastly, the mixture of water and essential oil will be collected in a vessel. The oil concentration will be 1.5 to 3%. Advantages of process to be used. Steam distillation is most used to produce many types of essential oil, such as from ginger. The process is cheaper than other extraction processes. It will not use any solvent and can make it safer than other processes. This process is easy to operate. Components of oil. Ginger essential oil consists of 10 compounds, where 3 are identical as monoterpenes and 4 compounds as sesquiterpenes. The dominant compound of this oil are zingiberine, which is in amount of 35.89%, beta bisabolene, which is 16.27%, beta sesquiphenyltreene, which is 11.56%, and curcumin, which is 12.18%. Geraniol is 9.9%. Geranoil is 9.4%. Nerol 7.1%. 1,8-cineol 6.2%. Alpha-terpineol 5.6%. Borneol 5.4%. Beta-phenyldrine 3.1%. Linalool 1.7%. Methyl nonyl ketone 1.6%, and camphene 1.4%. Ginger oleoresin is a blend of oil and resinoids. Oleoresin is obtained by extraction of dried ginger, pulverized to coarse powder with organic solvents like ethanol and acetone. The increased prominence of oleoresin over natural spices is due to the advantage that oleoresins hold over the spice themselves. Oleoresin content ranges from 3.5 to 9.5%. Processing of oleoresins. In solvent extraction process, the powdered samples are made from ginger rhizomes, which are first peeled, and then unpeeled ginger rhizomes, which are grinded and are treated with acetone solvent for first extraction. The solvent is then allowed to percolate the ginger sample for 48 hours before the first extraction were collected. The samples are then again re-soaked with addition of acetone for another 24 hours before collecting the second set of the extract. The extract from the sample is then pooled and the solvent is removed under rotavapor water bath. Extract is then poured in rotary evaporators, flask, and evaporated at 65 degrees centigrade till all the solvents is expelled. The concentrated extract, that is oleoresin, is then collected. Ginger root is first charged into the extraction vessel. This is for the other extraction processes, that is extraction by supercritical carbon dioxide. After the charging of the ginger root to the extraction vessel, the supercritical carbon dioxide is then fed from the holding tank to the extractor. The supercritical carbon dioxide is then passed through the root. The carbon dioxide and the extracted ginger oleoresin leave the extractor and enter the preheater, where the mixture is heated using low pressure steam. The pressure of the mixture is then throttled to 65 bar, causing the supercritical carbon dioxide to become a gas. The two-phase mixture then enters the flash vessel, where essentially all the liquid oleoresin exists from the bottom to the flash vessel. Essentially all the carbon dioxide exists at the top of the flash vessel and then is compressed and cooled back to supercritical pressure and temperature. The recycled carbon dioxide is then sent back to extraction vessel. After extraction, carbon dioxide and extracted ginger oleoresin enters a preheater and then a throttling valve. It's necessary to heat the mixture before entering the valve to keep the oleoresin above its freezing point of 31 degrees centigrade. Upon the reduction in pressure, the process is operated such that the entire amount of carbon dioxide in the holding tank is circulated through the process only once over the 6-hour extraction period. Once a given amount of carbon dioxide has passed through all the pieces of equipment, it's sent back to the storage tank, where it is accumulated for extraction of the next batch of ginger root. The process is then shut down for 2 hours while the spent ginger is removed from the extractor and new batch of the ginger root is charged to the extractor. Benefits of carbon dioxide extraction. Number first, the carbon dioxide does not extract any heavy metal like lead, mercury, etc. The heavy metals are found in the most plants as they are taken into the plant from the soil. Since high pressure is used, the microbial content is destroyed, giving a microbial-free material. This increases the shelf life of carbon dioxide extracts, and thereby the shelf life of food item is added to it. The shelf life is typically 2 to 5 years for carbon dioxide extracts. Carbon dioxide extracts do not require any special storage conditions and can be kept in normal room temperature, around 30 degrees centigrade. Carbon dioxide extracts are typically only 5% of the raw spice, and therefore the transportation cost and storage costs are lower. Added to this is the lower space required for the extract versus the raw spice. Carbon dioxide extracts versus solvent extract is not higher. It would be same if not lower than solvent extracts, as the product is purer and better. Extracts also give a more consistent quality from lot to lot. Ginger oil can vary in color from pale yellow to darker amber color. Also ranges from medium to watery. It is strong smelling oil, spicy sharp, warm and with hint of lemon and pepper, which smells of actual ginger. Ginger oil may be produced from fresh and dried rhizomes. Oil from dried rhizomes will have less of the low boiling point volatile compounds, since they tend to evaporate during the drying process. The difference between oil produced from the fresh and dried rhizome can be seen in the citral content, usually lower in the oil from dried plant material. Additionally, unpeeled or coated rhizomes are preferably used for oil or oleoresins extraction to improve yield. For steam distillation, dried rhizomes are ground to a coarser powder and loaded into a still. Live steam is passed through the powder, thus entering the volatile components, which are then condensed with cold water. Upon cooling, the oil separates from the water. Redistillation is practiced in India to increase the oil yield. Oil yield from dried rhizome is generally from 1.5 to 3%. Indian ginger yields 1.5 to 2.5%, often oil rich in citral. The rhizome powder, stripped from its oil, is made up about 50% of starch and may be used as livestock feed. It may also be further dried and powdered to produce an inferior spice. Problems arising during extraction. Generally, there are few problems that arise in ginger extraction. There are many types of extractions. The extraction can be conducted with or without solvent. But to get the essential oil, extraction through steam distillation is the most method used. Without any solvent, pure water is used at its boiling point as steam distillation to extract the essential oil from ginger. The steam is forced over the ginger. The steam will help to release the aromatic molecules from the ginger. The molecules of the volatile oils then escape from the ginger plant and evaporate into the hot steam. The temperature of the steam must be carefully controlled. It is because to control the ginger from burning and lose its purity. Ginger flavor is containing aromatic and pungent compound which is important in the flavor industry. But recovery of both components at the same time has not been possible by conventional separation processes. So, to recover both components, steam distillation unit must be designed. Ginger rhizomes constitute an aromatic and pungent spice that has unique culinary, medicinal, and commercial relevance to the economy of its growers and tropical and the characteristic pungent odor of peeled ginger rhizomes, which is due to its oleoresin, that is viscous thick material, which is an oily liquid containing oxymethyl phenols like shagol, zingerone, zingerol that are probably responsible for its antioxidant property. Are some of the therapeutic properties of ginger oil and oleoresins, which are analgesic, anti-emetic, antiseptic, antispasmodic, bactericidal, carminative, cephalic, expectorant, febrifuge, laxative, rebuficient, stimulant, stomach, sudorific, and tonic. So students, let's now summarize what we have learned in this module. Oil from ginger can be extracted using a variety of the methods, such as steam distillation and solvent extraction. Essential oils have a very high commercial value due to its therapeutic properties. It's widely used in aromatherapy medicine as well as flavoring food and drink industries. To get the approximately pure essential oil from raw material, conventional extraction technique like steam distillation is used. Steam distillation is unlikely solvent extraction. This is because steam distillation is to produce essential oils, but solvent extraction will produce oleoresins. Pure essential oil can be derived from a part of ginger plant. that is the ginger rhizome, by using steam distillation method. The extraction of the ginger essential oils began when steam contact to the ginger in the extraction tank. Ginger contains active substances that have antibacterial, antiflutulant, antimicrobial, anti-inflammatory, antiseptic, antispasm, antiviral, and antioxidative properties. So that's all about the essential oil and oleoresins. Thank you very much.
Dear students, now you have seen how important this particular process of bleaching in the case of ginger is, which has been explained by my co-author. Now after bleaching of the ginger, the next step is to produce the ginger products, and this particular aspects will be explained to you in the next module, ginger and its products. Thank you.